Do you see the math as scary in statistics?
Yes, it's totally scary. I hate math. Math hates me. Yeah, math is scary and math is really hard.
People who are scared of the math, they can be like, oh, well, Josh is also scared of the math still, and he's like the king of statistics on YouTube.
I've got one last thing for you.
Let's go ahead.
Triple bam.
That's what I was hoping we were going to end on, was a triple bam.
Welcome to the Data Career Podcast, the podcast that helps aspiring data professionals land their next data job. Here's your host, Avery Smith.
Bam! Welcome back to the Data Career Podcast. I'm here with Josh Starmer PhD, better known as StatQuest right here on YouTube.
Bam.
The famous BAM. If you guys haven't checked out Josh before or StatQuest, you guys got to check it out on YouTube. Basically, in my opinion, you've made so many contributions to the statistics and data analytics and data science community with all these statistics YouTube videos that you've made. First off, thank you.
My pleasure.
Second off, though, really Josh's role in society is he's basically the YouTube that you turn on when you have a midterm in college for your stats class. That's basically what Josh's life work is.
Right.
Is he's the person you turn on when you have a stats midterm in the middle of the semester. How does it make you feel?
It makes me feel pretty special because it could have been anyone and it ended up being me.
Well, we appreciate it. We're going to talk about Josh's background and how he got into statistics. We're going to get into a little bit about what you need to know with statistics in this episode. So be ready. Here we go. All right, my first question. We're going to get to your background here in a second, but I want to start with I help a lot of new people who are transitioning teachers or they're warehouse workers and they want to become data analysts.
Okay.
So these are people that maybe got an English degree or a teaching degree, or maybe they didn't even go to college and they want to become data analysts. A lot of the times they're scared about math. Do you see the math as scary in statistics?
Yes.
Really?
Yeah, it's totally scary. I hate math. Math hates me. I don't work well with symbols, and I don't work well. I know I don't want to offend anyone in the wonderfully beautiful country of Greece, but when I start seeing Greek characters on a page, my hands start to sweat. Math is for me very hard and very intimidating, and I've been working with it my whole life, and I still, when I see equations, I'm just talking about it, I get sweaty palms right now. Math is scary. Yeah, math is scary and math is really hard. It is for me at least. Yeah, it's super hard.
That's so interesting.
Yeah.
So, but even though you make all these YouTube videos, you work for an AI company, you're still kind of a little bit scared.
Yeah, exactly. It's a little bit like, I guess mountain climbing or whatever. I see the equation and it intimidates me. It's so big and tall, but part of me also wants to understand it because I know what it does. It's this real compact thing, but it's somehow very powerful. And so I want to understand why it's powerful and what gives it its power and what the big deal is. I feel like when I see an equation, I guess I get that fear of missing out thing. There's something encoded in there that I don't get it. And everyone else is like, check it out. I get it. I understand it. I'm like, what? But I don't get it. And so that's another thing. Yeah. So I know it can do cool things. I just want to understand it. So I will persevere and I'll climb that mountain. I don't care how tall it is. And I'll get to the top. And I'll be honest, this is the other thing that, even though these things scare the dickens out of me, when I get to the top of that mountain, and I solve not solve the equation, but I figure out what the equation means and represents, it's one of the best feelings ever. I just get such a rush, and it is like climbing a mountain or accomplishing some other goal that was difficult, and you had to persevere, and you finally got it, and you know how proud of yourself you are when you finally did it. That's me when I've finally understood an equation.
That's so interesting because now Josh and I met, I think, twice now, kind of on these prolonged little trips. We should also mention that thank you to Posit for bringing us here together.
Yeah.
But I've learned that, Josh, if you guys have watched his videos, you know that he loves math. He loves to sing and play music. Josh also loves to cook.
I do.
And so I feel like all
Yeah.
three of those things are things you were probably just like really curious about, and you're like, I want to understand how does that sound get made, or how does this amazing steak get cooked?
Yeah, it's true. There's a lot of curiosity in what drives me is curiosity almost for everything.
That's so interesting.
Yeah, I taste something, I go, how did this happen? I hear something and I go, how did that happen? And I want to figure out how to recreate it or make it myself and kind of break it down into the pieces and just understand.
Makes sense. And really, what I was asking is the math scary problem.
Yeah.
I tell people the math isn't scary.
It's not scary.
That's what I say. But no, that's good. You say your true opinion. But what my point here is I think it's actually awesome that like people who are scared of the math, they can be like, oh, well, Josh is also scared of the math still, and he's like the king of statistics on YouTube. So it's like, is statistics scary? Yes, but Josh did it, and if Josh did it, I can do it too.
Yeah, I hope that inspires some people because it's very true. It's not about looking at an equation and going, oh, that looks easy. It's not about that. It's about, or that looks hard or something like that. It's everyone can understand these things. And even the most complicated equation really is just little pieces of it, relatively simple things combined, right? You can have a really dense equation, but it's just addition and multiplication, and we all learned how to do that in second grade or third grade or maybe fourth grade. I don't know when I learned it. It was a long time ago. But you know what I'm saying? Like when you break it into the smaller pieces, you can get it down to something where it's understandable. And then I start playing around with it, and sooner or later I start seeing what it's really doing. Once I can see the individual pieces doing their thing.
And that's something you're really good at in your videos. They're all very like modular almost. It's like furniture where it's like you could switch it, like you learn one thing and it applies here, it applies there. And you do that as well in your book.
Yeah.
Is it the Illustrated Guide for Machine Learning? Is that the name of it?
It is the StatQuest Illustrated Guide to Machine Learning. Yeah.
If you guys haven't checked that out, we'll have a link to it down below. If you're just starting out in the data world, machine learning might be a little bit much, but if you're like ready to learn machine learning, I wish I would have started with your book because first off, you do two things really well. Number one is you do what you just said, where you make it like very modularized, one bit at a time, where it's like, I'm not just taking machine learning a whole. You like help me start at like things I kind of recognize from stats class, maybe like a p-value. We'll get to that in a little bit. And then also you make it really fun.
Yeah.
It has like a bunch of cartoon drawings. And honestly, I think you changed the format of the book right now.
Yeah, it used to be a landscape, and now it's a portrait.
So now it's more normal. But the original landscape,
I know.
it was a piece of art. I'm sure the new one's a piece of art too. But it looked like it could like belong in a pop art museum.
Yeah, I was really pleased with the original version, but unfortunately, I couldn't get that one printed internationally. So I had, in order to get the book more places, I had to reformat the whole thing. It took like 2 months.
You were doing that last time.
I was in the basement of the house where everyone was, and I was just like a machine, just going crazy, just reformatting every single page. But I did it.
You did it.
Yeah.
And it's out.
Yeah.
Anyways, I love the book. I think it's really great. If you're just getting into machine learning, honestly, I think this is something you need. And if you're like me, where it's like, I've been doing machine learning since, I don't know, 2016? So almost 8 years now.
Dang.
But like, I also am not like in the trenches of machine learning every day. Like yesterday we had a hackathon and that was like my first time coding hardcore in like a couple months.
Yeah.
And I was like, oh yeah, this is kind of get on your bike. Anyways,
Yeah.
the book's really good for that for me. Cause it's like, oh yeah, wait, what are the rules of this? And I can always go back and check the book. And anyways, love the book. Let's talk about like for people who are just getting into statistics.
Okay.
What are like if you're just learning statistics, you're just getting started, what are like 3 things that someone should know? Let's start with one.
And this is going to sound weird, and it actually really applies to anything, not just statistics, but learn how you learn. Like we were just talking about how scared I am of equations. When I took statistics, they just put a bunch of equations on the board or the wall or and they just said, this is the equation for variance. This is the equation for the mean. This is the equation for this thing called a t-test. And there was just a bunch of equations, and none of it made any sense at all to me. Now, does that mean I'm never going to be a good statistician? Does that mean I should just pick another job, career or class or something like that? And the answer is no, because it just meant that looking at a bunch of equations isn't the way I learn. I'm a real visual learner, and I did not learn statistics during that class at all, and I got a really bad grade. But 5 years later, I mean, I knew I had to learn statistics for my job, and I knew I had to figure it out. So I just started trying to use pictures, and I drew pictures about what was going on, and I tried to illustrate what the equation was doing. And when I did that, I got it. And as a result, I became quite an accomplished statistician. And one that's, I mean, I feel like I'm bragging, but I was highly respected. People came to me for all kinds of problems because what they discovered is I didn't just know the equations, I actually knew what was happening. I knew what was really going on. And I'd learned it in an incredibly deep way. And it was all just because I found another way to learn. So I think for any topic, but especially statistics, I personally had struggled with that one. Because to me, it's a weird topic. It's unlike anything you're taught in grade school, for example. Like when you take math in grade school, your high school calculus or whatever, all those things, there's one answer. And that answer is like just one number. And so our whole lives, up to a certain point, is all about solving for single individual numbers. And statistics is using those same mathematical techniques, addition, multiplication, not that complicated stuff, but the results are weird in that it's not just a number. It's a mean plus variation. What does that mean? And why can't I just use the mean all the time? Why isn't that good enough? Because it used to be I could, like when you were in high school, they're like, calculate the average. And you calculate the average and you get a number. And that was good enough then. Why isn't it good enough now? So I had a lot of conceptual difficulty wrapping my brain around the fact that I was using math, but I wasn't, the old things that I was doing weren't good enough all of a sudden. And I didn't understand why, and I didn't understand anything that was going on, because it was all things I'd done before, but in a way that made no sense. And so it was very hard for me. So I'm just saying, like, for statistics was when it was a profound thing where I had to find a new way to learn that wasn't just by looking at equations and doing whatever we did in the class, because that didn't work for me. And so I think that's what it's important for anyone. It was super important for me. So when you're starting out statistics and you're like, I hate this, I don't get it, it doesn't make any sense, maybe it's because you're learning the wrong way, or you're being taught the wrong way, and it's not the teacher's fault. Every one of these different. Some people are going to respond positively to the way that teacher's teaching. So it's kind of up to you, or it's up to me to find a way to make it work on my own. I mean, and one thing that's nice is there are lots of YouTube channels. There's mine, obviously, but there's lots of others that have different approaches. So you can try mine and go, it doesn't work for me. And you can try someone else's, and you can find someone that does resonate with you. And so it's not like, I'm throwing you out and making you have to learn all this stuff on your own. There's teachers out there. You just have to find the one. And it may not be the first one you find, but hopefully you'll find it sooner or later.
Yeah. Figuring out what actually works for you and your learning style is so important, because actually I'm usually, like, in college, I pretty much played a golf game on my phone while I was there, because I don't learn from like a PowerPoint presentation. So like I go to class and I try to listen and I get bored and I would just play golf on my phone.
Yeah.
And then I'd actually learn by doing the homework.
Yeah.
It's like, okay, I go do the homework. Oh, okay, now I understand why I kind of need to do this.
Yeah.
I'd go like in the book, read, okay, that makes more sense for me.
Yeah.
And usually I don't really like theory very much, which is what you kind of do in your videos.
That's what I
a lot of the
do.
time.
Yeah, a lot of theory.
Which is awesome, because if you want theory and theory works for you, watch Josh. I don't really cover statistics that much, but I'm like very practical.
Yeah.
Like most of my YouTube videos are like, this is how you do this data analysis with this data in this situation. It's like way too practical. But the cool thing is some people are going to resonate with yours, and some people are going to resonate with mine, and that's great. You got to figure out what works best.
Exactly. Yeah.
Okay, so that's the first thing. Figure out how you learn.
Yeah.
The next thing, if you figured out what you learn, what should you learn next in statistics?
The next thing is try to wrap your brain around the concept of variation and variance. The whole reason for statistics to begin with is variance and variation. When I was talking about, when we learned how to calculate the mean in high school, they didn't then say, and now calculate the variance of it. And so when I finally had to start doing that, I was like, what is going on? Why can't I just why don't I just report one number? Why do I also talk about variance? But what statistics is every time we do something, every time we see something or experience something, every time I go to my favorite restaurant and I order French fries, I get a different number of French fries. Or different sizes or different, it's never the same order of French fries, 10 times in a row. It's never exactly the same, right? And so what do we do about that? Can I use that variation as a way to make informed decisions? For example, where am I going to get the most French fries most often? Like, there might be some restaurant that like occasionally gives me tons of French fries, but it's rare, and usually they only give me a little bit. And there might be another place that's like all over the place all the time, and we can use that variation. Statistics, what it does is it takes that variation and quantifies it. And once it's quantified, we can use it to make informed decisions. And that's the power of statistics in a nutshell. It's all about quantifying, understanding, and using variation to make informed decisions.
Very good definition. I like that definition. You can see that Josh is a very he's got these concepts defined in his head.
Yeah.
Very well. I like that because basically statistics does exist for variation and trying to figure out, because we as humans we know that okay, this is more French fries than this French fry, but you can't remember last week's or 5 months ago's French fry size or the number of French fries. And so really what that allows us to do is take the variation or the differences in occurrences in life and put it into a numerical form.
Yeah.
And we as humans can be like, oh, 10 is bigger than 5.
Yeah.
And so then we can make, like you said, informed decisions. So I really like that definition.
Hooray.
All right, good. Yeah. Bam.
That's a bam.
Yeah, that's a bam right there. Okay, so we got learn how to learn.
Yeah.
We got understand variation. What's the third thing?
The third one is, I don't know exactly what the right word for it is, but what I call it experiment with whatever the thing you're learning. If you have a computer, if you've got Excel, you can if I learn a new statistical concept. So there's this thing in statistics called the central limit theorem. And if you look at the equation for the central limit theorem, it's really complicated.
It makes me yawn just thinking about it.
It's this horrible, intimidating thing. But what that equation means is that, and this is going to sound weird, when we calculate averages for something, say the average number of French fries, we'll say I calculate the average of the French fries at the restaurants I go to, and you go to those same restaurants a day later or whatever, and you calculate the average on the days you go to, and then maybe somebody else goes the next day and they calculate the average. Say we got 10 people and we all calculated our averages. Well, if we plotted a histogram of those averages, it would have a bell-shaped curve. It would be approximately what we call approximately normal in statistics. And but doing all that work, getting my 10 friends to eat French fries 10 days in a row, and then repeat that 10 times or something like that, getting everyone so everyone has 10 measurements that they can use to calculate their mean. That takes really time consuming.
Yeah, it's a lot of French fries.
It's a lot of French fries, and I do love French fries, but I may not want to wait 10 days before I get my next order in. You know what I'm saying? So what's cool is I can simulate that on a computer. I can write a program to generate a random number of French fries and do it 10 times and then calculate the mean and then repeat that process 10 times. So I've got 10 means, and then I can do it in Excel and I can plot a histogram and I can see it. And then there's this huge complicated equation that just boils down to this nice histogram that looks like a curve, and then I can say, well, what happens if we all order small fries? Does it change? So instead of the random number of French fries being like a reasonable number of French fries, like 20 or 30, maybe we only get 5, or on average. What happens to that histogram? Does it get wider? Does it get narrower? What happens if we order supersized fries? So we get like 100 fries with each order. Does that change the shape of the curve? I can do all this stuff on a computer, and I can play with it, and I can see what happens. And the more I play with it, the more I understand what's going on. And then when someone goes, well, we're only collecting this much data, but we're going to assume it's normally distributed because you have to do that for certain statistical tests, I'll look at them and I go, well, that's going to be a kind of a rough approximation. Or they'll say, we're getting all this data, and I'll be like, and I'll know because of those experiments that I did that that's going to be a really good approximation. So that's a way that I've learned statistics, is just by playing with it and experimenting on my computer in Excel or R or whatever tool you want to use. That's how I've learned a lot about statistics.
Just playing around,
having a good time, thinking about French fries.
Practice, yeah. It does help if you make your statistics more French fries,
That's right.
or donuts or something.
Yeah, exactly. Yeah, if you're not a savory guy, you can do donuts.
Yeah.
Yeah.
Maybe donut bites. How many donut
Yeah,
bites?
donut holes. Yeah.
Yeah. That's so interesting.
Yeah.
So the learn how to learn.
Yeah. The second one is understand variance, or try
that's right.
really hard to understand variance. And to give you a tip on understanding variance, I always draw things. I try to illustrate what variance means in this context. And so that's something you can.
Okay.
And
then experiment.
I would do it visually, and then experiment.
That's so interesting.
Yeah.
So when I originally wrote this question,
Yeah.
I thought the answer was going to be p-values, hypothesis testing, and regression.
No.
But I think that just goes to show how like practical I am, and like I'm like, but anyways, that's so interesting. that like really at the end of the day, what you're saying is the most important thing about statistics is like spend time with statistics, like practice. It's like no one actually really understands it the first time they hear it, and you get better at it as you go.
Yeah, it's a weird field, and it doesn't make a lot of sense to a lot of people because they haven't really spent a lot of time playing with it, I think. And all of a sudden you're like, okay, I get it. Play with it.
That's so interesting.
Yeah.
I wanna kind of change gears. Oh,
Okay.
Actually, let's talk about this though. Memorization.
Yes.
This is something this is like a question that I have in
Yeah.
general. Like, do you have like all of like stats memorized?
No.
Should you?
No. I'm a main idea person, to be honest. I am very bad with details, and especially memorization. And so I don't think it's that important. I've got a terrible memory. I forget all the time. And so, I mean, there's certain things you need to remember, which is like main ideas, like what variance represents,
Sure.
right? And I feel like you need to have those concepts like really well down, really well. But in terms of like, what's the equation for doing a linear regression? I might not even know that off the top of my head. T-tests, which is a t-test is a sort of a fundamental statistical test. I could not tell you what the equation is for that. Most things I couldn't tell you the equation for.
The concepts are important to quote unquote have memorized, or at least understand what they are.
Yeah. And one of the reasons why is like you never actually use the equations yourself, right? You plug it into Excel and it gives you the answer. And what's important is you know how to interpret that answer rather than like, oh, I know exactly how it's doing this and it's dividing by this and it has this thing called degrees of freedom and blah, blah, blah. You don't have to remember those things. What's important is that you've got your data, you put it in your spreadsheet, you put it in R or whatever you're using. You did the test. Here's the output. What does it mean? Who cares how it was done? You just want to know what it means.
So the concepts and interpreting the results, which is actually interesting because I just interviewed Alex the analyst. One of the things that we talked about that makes a good analyst is like less your technical skills and more your ability to explain what you did technically and how it relates to the business, which kind of statistics, it's the same. It's like, it's not like, do you have, like a t-test formula memorized? It's like, can you know the situation where you'd want to use a t-test, have a computer use it, and then being able to interpret the results?
Exactly, yeah. So there's some memory involved. You got to understand that there's times when this test is useful and there's times that it isn't. And you have to remember those little details. But in terms of the nitty-gritty stuff, you don't have to remember any of that.
Okay, very neat. I want to go kind of like back into time.
Okay.
Back to when you were in school. You got a music degree.
I do.
But then you also got a computer science degree.
I did, yeah.
Which is interesting because a lot of people, I've actually I've helped a few musicians who have music degrees become data analysts. I've helped a music therapist. I don't know if you've ever heard of that.
Oh, yeah.
Yeah, became a data analyst. Aaron Sheena, I think episode like 57 or something like that. But it's so interesting because a lot of them never have the computer science degree. So you did both as an undergrad.
Yeah.
And then you went to biostatistics, is that right?
Yeah. Yeah, I have a PhD in something called bioinformatics.
Bioinformatics.
Yeah.
Okay.
It's biostatistics.
So you've always been kind of curious about computers and math and stuff like that.
Yeah, I mean, when I was a kid, I was really just drawn to computers. I mean, I like to play outside too and climb trees. That was also fun. But I've always felt some affinity towards computers, and I don't really know why. I don't know, but I don't know. Like when I was a kid, I used to try to make my own video games and things like that. I just thought it was fun to do, and so when I went to college, I loved music and I loved computers, and so I did both. And it turned out that I've actually had the opportunity to do both professionally. And it turns out I don't like doing either one without the other. If I'm coding all day, I love going home and playing music all night.
Yeah.
And if I'm playing music all day, I used to be in a touring rock and roll band and do some things like that. That's fine, but when I go home, I want to code and do math all night or whatever. Work on data science all night. I just love. I love it all. And so it's been. I feel very fortunate that I've been able to pursue both.
It's very neat to do both. And if you haven't watched Josh's YouTube, you'll go watch one and you'll understand how he uses music and
in a very silly, unprofessional way.
It's awesome. It's very awesome.
Yeah.
But so anyways, you end up working in a lab.
Yeah.
And you have this, bioinformatics PhD.
Yeah.
And so everyone's kind of asking you, hey, Josh, I got this, I'm doing the stats thing.
Yeah.
Or like, how do I do this?
Yeah.
And the people just keep coming and asking you kind of the same question. And one day you get sick of it.
Yeah.
And you're like, I'm going to make a video that explains it.
That's kind of how it happened. It was partly that I think all computer programmers don't like doing the same thing more than once.
Yes.
They like the variety, and so I think I had an impetus or a motive to teach the people around me how to do their own stats. I wanted them to present with confidence. I wanted them to understand what they were doing and how they were doing it, so that if someone asked them a tricky question, they could respond correctly. And so I started making these videos. Well, what I started off teaching people the concepts, and they were basic, really crummy PowerPoint presentations, not fancy looking at all. But I would do these things, and at the time I called them stat chats, Friday morning stat chats. But it was an academic lab, and so I started having to repeat the lectures because there'd be new people in the lab, and again, I don't really like doing the same thing more than once, and so I was like, I got an idea. I'm going to put the videos of these presentations. I'll put them up as YouTube videos, and it solved all kinds of problems. Not just the having to repeat myself, but one thing that's really cool about YouTube that is it meant that the people in the lab could learn when they needed to learn rather than when I had
Friday
time
mornings,
to teach, right? And what's important about that is, like, I could teach them some statistical concepts. I could say, hey, on Friday we're going to talk about variance, and they'd be like, great. And they would come and they would learn about variance, and then they'd go maybe a year and a half before they actually need to do anything, right?
Yeah.
And by then they've forgotten and maybe gotten it confused, and it was like that time was just wasted.
Yeah.
And learning takes work. It takes work to teach, and it takes work to learn. Your brain has to change. That's work.
Yep.
And so we all did work for no reason at all, because by the time they needed it, they'd forgotten and they have to relearn. And so what was cool about YouTube is I would just put it up there, and they'd be like, well, I'm reading this manuscript, and it says that it's got this thing called R squared, and I don't know what the heck that is, but I'm going to check Josh's channel, and look, he's got a video on it. I can learn it when I need it and when I'm using it. And so that was like a real big plus for YouTube. And it wasn't about... And so anyways, my early videos are all... I used to work in a mouse genetics lab, so all my videos were designed just for my coworkers. All the examples are like, imagine you have a mouse that weighs this much and it's this big, blah, blah, blah. So they're all mouse genetics examples. And I'm talking about genes because these are geneticists. And it's funny, a lot of people watch my videos now and they're like, these examples are terrible. They're like, why are you talking about mouse genetics? I'm not a mouse geneticist. But the purpose was not to have videos that everybody watched. I was really just trying to help my coworkers specifically. And that's something I think was also very important, maybe to my success, was I knew who my audience was.
Yeah.
I wasn't just being like, I think I can teach R squared. Here's what I'm going to do. My attitude was like, I'm trying to teach R squared to these specific people. What's the best way for me to do that? And the best way for me to do that for them was to use mouse examples, because that's what they could relate to that. A lot of statistics, for me, is hard to... When I'm learning statistics, one thing that's really hard is because it can be applied in so many different contexts, and this probably bothers you too. They use the most abstract examples ever. They're like, imagine you have an urn filled with 2 different types of marbles. And I'm like, what?
Who cares? Yeah.
Yeah, I'm like, why should I do that? So I'm like, okay, you've got these mice. And so immediately, my coworkers, they wouldn't have to imagine something that was kind of abstract. They could imagine something that they work with every day, and they could relate to it. Yeah. And I think that was a big part, was knowing who I was trying to communicate to, and not just being like, oh, this is for everybody, and being really general about it. I tried to be real specific and give lots of specific details so that the people that watch it could relate.
For me, that's always really useful, because like even now when I think about doing like some more complex machine learning stuff, like PCA and like clustering and classification and stuff like that, I think back to when I was working and I was using it when I originally learned it, like those examples, and I always think through all of the actual math in those examples, and then I always try to relate it to what I'm doing now. Okay, that's how I did it then. What's this part? Anyways, so that is really useful. And one thing I just want to highlight is from you were as a like biostatistician, bioinformaticist or something like that. Your job wasn't to do that necessarily, but you were documenting your learnings, and like your whole life looks different because you documented your learnings.
That's true, yeah.
But one thing that they actually said, one of the posts that people said was every data scientist is a content creator. And I thought it was kind of weird at first. But now when I look back at it, it's like anyone who's doing anything technical, you're always going to get benefit out of documenting your learnings and sharing with others.
Yeah.
And like your life would look a lot different if you never had done that.
That's exactly right.
Which is crazy, because it's hard to know in the moment. It's scary. I mean, maybe at the time you're just putting yourself on YouTube for them, not for other people to see. But anytime you're making any sort of videos, your voice or your face could be on there, and it's scary and stuff like that. And I just think there's so much to be benefited by, sharing your learnings as you go.
Yep.
Your whole life is different.
That's why it's called StatQuest.
Yeah.
It started out as my quest to learn statistics. It was my adventure.
Yeah. And you weren't even, I think you told me this last time, like sometimes you'd make the videos to understand the concepts.
Yeah, exactly. Yeah.
Like it was just you learning in public.
Exactly. Yeah, that's how it works. Is I learn in public in front of everybody, with a lot of people watching.
Which is scary.
Yeah.
Which is scary, but there's so much to be benefit from it. And
Yeah.
that's one of the things I try to work with my students is like, just post on LinkedIn what you're learning.
Yeah.
And like, you'd be amazed what doors can be open.
Yeah, you can build communities that way and make friends and help people too, because someone might say, hey, you're learning that, I'm learning it too, but I couldn't figure this part out, or it's like it's yeah, it's great. It's really great because I think although learning is work and hard, I think it's also fun, and it's a fun activity, and it's fun to do with other people, even if it's remotely and things like that.
Better than doing it by yourself.
Yeah, always.
A lot of the time. All right, Josh.
Yeah.
That's all we had for today. Can we end with one more thing?
I've got one last thing for you.
Let's go ahead.
Triple bam.
That's what I was hoping we were going to end on, was a triple bam. So if you guys don't follow Josh, make sure you go check. We'll have his link to his YouTube down below, and we'll have a link to his book. You guys can check that out. Before I met Josh, I bought a copy, so I'm not biased in saying it's a great book.
Right.
And even last time you had a few copies that I think you gave to people, and I was like, I bought mine. I have an original. It's signed by Josh now, so go check it out, guys. All right, thanks, Josh.
Yeah, thank you.